to Joe Newton online class. In this class, we are going to look into this calculation, which is taken from the topic capacitor, that is capacitance or capacitors. And it is a topic in physics. Now let's look at the question. But before that, what do you mean by capacitance of a capacitor, or what is a capacitor in the first place? A capacitor is an electronic device used for storing charge or storing electricity. That is a capacitor. Some appliances like electric fan, devices like generator, most of them, our computer system, all of them have capacitors. Then we have capacitors arrangement. It could be arranged in series, that is head to head. It could be arranged in parallel, that is one line over another line in parallel. And each one has its effect in the capacitance of that capacitors when arranged. Like what? We have the different formula for solving or determining the capacitance of capacitors when arranged either in series or in parallel. Okay, now let's look at the question on board. Two capacitors or capacitances, 2 microfarad. This is microfarad and the 3 microfarad, because the unit of the capacitance of a capacitor is what? Farad. And recall that capacitance of a capacitor is the quantity of charge per unit volts applied across the capacitor. That is the ability of that capacitor to store electricity. That is the capacitance of a capacitor. And it is measured in farad. Okay. Now, are connected. Then what is the equivalent capacitances if connected I in series, II in parallel? Quickly, solution. We have 2 capacitors. Let's label them C1 is equal to 2 microfarad, and our C2 is equal to 3 microfarad. Then we are now asked to find when in series. In series connection, then the capacitance in series. Capacitance in series. In series connection, the total capacitance, now let me call it C total, the equivalent capacitance is given by a reciprocal, unlike that of resistors. Because for resistors, in series connection, we don't do summation, simple algebraic addition. Then in parallel, we take the reciprocals. So in the case of capacitance, we take the opposite operation of that resistor or resistances. So that of capacitance, in series connection, we take the reciprocals. Then therefore, for us to get the net or equivalent capacitance. But in parallel connection, we take the word algebraic sum, that is addition. Now, that will give us here, for the first one in series, we have 1 over C total is equal to 1 over C1 plus 1 over C2. Then, which is equal to 1 over C total is equal to, remember to start with reciprocal of the word, the equivalent. Reciprocal of the equivalent. 1 over C total, reciprocal of the equivalent, goes to 1 over our C1 is 2 plus 1 over 3. Take the LCM here. Our LCM is what? 6. Then 2 divided 6, 3 times 1, 3, plus 3 divided 6, 2 times 1, 2. Giving us here 5 over what? 6. Therefore, our 1 over C total is equal to 5 over 6. Which means by implication, our C total, you take the reciprocal of this, will now be equal to 6 over 5, which is equal to 5 divided 6, have one whole number, 1 over 5. And 1 over 5 is 0.2, goes to 1.2, what you get about 1.2 microfarad. Then if you want to convert to farad, recall that 1 microfarad is equal to 10 raised to the power 6, 10 raised to the power minus 6 farad. That's for micro. But 1 millifarad is equal to 10 raised to the power minus 3 farad. In case you want to convert to farad, if the question demands that, you multiply this by 10 raised to the power minus 6. Okay. Then II, very simple. The equivalent capacitance in what? Parallel. Capacitance in parallel. So if the capacitors are connected in parallel, the capacitance in parallel connection will be simple. C total is equal to linear addition plus C2. Continue depending on how many capacitors you have, which will give us our C1 is what? 2 microfarad plus our C2 is 3 microfarad, giving us a total of 2 plus 3 is simple 5 microfarad. So you can now notice that for you to get maximum capacitance in the system, you have to connect them in what? In parallel to raise your capacitance. But if you want to minimize the effective capacitance there, you arrange them in what? In series, which is an opposite operation to resistors. For resistors, to maximize, you connect in series. To minimize the effectiveness, you connect in what? Parallel. Because resistors oppose flow of electricity, while capacitors stores electricity. Thank you so much for paying attention to this particular class. I hope you enjoyed it. For more of these solutions, special calculations in physics and mathematics, and other explanation of concepts and practicals, visit my YouTube channel at Joe Newton Online Class. Also follow me on Facebook page, Instagram, TikTok, like and share for others to enjoy.